Defense of the homework of the subject of network communications by Lieutenant Patiño Darwin. I'm going to defend the problem 2-4, and the problem says like this. Assume a system uses 5 protocol layers. If the application program creates a message of 100 bytes, and each layer, including the fifth and the first, add a header of 10 bytes to the data unit. What is the efficiency? The radio application layer bytes to the number of bytes transmitted of the system. Okay, the application layer creates a message of 100 bytes. Each of the 5 layers add a 10 byte header, so the total overhead is. We have a 5 layers. This value is multiplied by 10 bytes. This is equal to 15 bytes. This result is the total headers. The total number of bytes transmitted is 100 bytes. 100 bytes plus total headers is equal to 150 bytes. But the efficiency is equal to the radio of application data to the total data transmitted is the number of total bytes in 100 bytes is divided by 150 bytes. This is equal to 67% efficiency. And that is all of my homework.
Hello, in this video I will explain how I solved the problem number 15, chapter 2 of the book Data Communications and Networking. Using the internet in figure 111, chapter 1, in the text shows the layer of the TCP suite and the flow of the data when the two hosts, one on the west coast and the other one the east coast, and message. The following image shows how information flows through the layers on the TCP/IP model when two computer hosts or on the west coast and the other east coast send messages to each other on the internet using figure 111 in the books as reference. Okay, first let's look at the setup. We have two offices, one on the west coast and one on the east coast. Each office has a computer or host connected to local area network LAN using a switch. These LANs are connected through a wider network WAN using two routers R1 and router R2. West2 data flow the West2 to 8. When the host of the west coast wants to send a message to the host, um, its codes, the data moves downward through on 5 layers on the TCP/IP model. Uh, first, first layer is physical layer. Um, okay, and first application, physical application layer. Two layer is transport and 3 layer network, data link 4 layer and physical 5 layer physical. Uh, the data travels through the switch, then to router R1, and is transmitted through the one link to router R2 on the EX codes. Um, the reception um, in EX codes of uh, that information is, is where page router R2 pass the message of to the destination host. Uh, now the data moves over through the layers. First physical layer, and 2 data link layer, 3 network layer, 4 transport layer, and 5 application layer. In the diagram, the red verticals arrows represent the flow of the data through the TCP/IP layers within each host. The horizontal lines show how the data travels physical through switches and routers over the network. In conclusion, this example is perfectly illustrates how each layer in the TCP/IP model plays of a specific role, ensuring that a message can be created, transmitted, delivered, and accurately between two computers across the internet. Thanks for watching.